In this video, we'll have a quick look at the parts of a control system. First off, we need to start with a system that has its inputs and outputs defined. This is shown visually in engineering with a block diagram indicating what the inputs and outputs are, and if possible, where they come from or go to. Later on, we'll add more blocks to see how inputs can flow through multiple blocks before finally having an effect on the output. For this video, we will consider only one input and one output. Our goal is then to control the output by changing the input of the system. In order to do this well, we need to predict how the system would respond to changes in the inputs. The model developed is often stated in the Laplace domain, and the equation is called a transfer function. An example of such a system is a water tank, where the input flow rate is the input and the water level is the output of the system. So how do we go about controlling the system? The most simple is manual control, where you control the input directly. This isn't always the most easy or convenient method. Sometimes the relationship between the input and output isn't intuitive, or the output changes too fast for a human to control. In most cases, having someone controlling the input 24/7 is not practical. To automate this, we use a controller, which is a device that when provided a set point will do all the work required to try and move the output closer to the set point. For example, to increase the temperature to the required set point, the controller could increase the power to the heater, much like a human operator would. A difference between a human operator and a controller, however, is that you could design the controller to know how much power to increase in order to obtain the required increase in temperature, whereas a human would have to guess and check. In this form, we have a control structure known as a feed-forward system, and although it is very simple, there are some limitations. A feed-forward system does not measure what it is trying to control, so the controller has no way of knowing whether the changes it is applying are working correctly. An analogy to this is trying to walk somewhere while blind. Without checking to see whether you have moved in the correct direction, you eventually wander away from where you would like to go, and if someone pushes you slightly, then you would lose your orientation and you would have no idea where to move in order to reach your destination anymore. To solve this, we can add some feedback to the system so the controller can see where the output is at the moment and thus determine what it needs to do in order to make the output equal to the set point. This is done by subtracting the set point from the actual output signal to calculate the error. The controller's aim is then to make the error value go to 0. The addition of the feedback loop improves the performance of the controller by allowing it to compensate for errors and disturbances which would have thrown the feed-forward system off track. The actual mass inside the controller varies greatly, and a lot of research has been done and is still being done to find controllers that can attain its set point quickly without causing undesirable behavior such as oscillations and overshoots. Examples of controllers are proportional controllers and PID controllers. Of all the controllers, PID is the most common as it can easily achieve good performance without requiring a detailed model of the system it is trying to control. PID controllers are also relatively simple to design and implement. In reality, controllers are implemented with electronics, and so the inputs and outputs of the controller must also be electrical. Devices such as actuators, valves, and sensors thus serve as an interface between the controller and the physical world. Returning to the water level example, a possible way to implement the control system is to install a water level sensor and control valve as shown. The controller would then operate by controlling the valve using feedback from the water level sensor to ensure the output is changing to the desired set point. And this completes a brief introduction on the parts of a control system.